All right, so over the years, I've been trying to kind of unify the concept of sound reinforcement, sound playback, and all these inherent hypocrisies and conflicts that seem to exist between the various art forms or various trades in the industry. I mean, on one hand, we have guitars and guitar amps and resonant panels on violins and instruments that are made of flimsy things that have all these overtones and complexities, and running into Celestion speakers that distort and break up into tube amps with distortion pedals, and everything is all messy on the front end, whether it's the acoustic instrument or the way that it's being reproduced. Open back guitar amps with resonances and chambers, and it's just a mess. So we take these messy sounds, and the messier the better. The more complex the better. And then we capture them with a wide variety of microphones, ranging from extremely accurate, like an analyzer mic, which we don't use for recording because it's too accurate, and all these other mics that have colorations and sound variations. Again, adding more complexity to the sound sources. And after we've messed with everything and created this cacophony of kludge, we then capture it in the most perfect, accurate way possible in the console and try and get 24-bit, 48-bit, 96K, just 192K. Perfection. Everything has to be perfect. We've grabbed a big pile of crap, or seemingly crap, or beauty, and then, once it's grabbed, the mess is done. Now we need perfection all the way through the signal chain to get into a speaker that then radiates it into the room and tries to do exactly whatever that mess we started with was, that we mic'd with a bunch of different mics and we put a guitar rig and a snare drum in a bathroom. How does this make sense? What is the common thread that connects all of this together where it makes sense? And I don't believe it's a mystery. It's actually a logical progression. But there's some lack of insight. There's some flaws to the system. And I think for those of you that are members, thank you. And if you're wondering why I'm messing with this real sounding speaker and not looking at pro audio stuff and kind of diving into the hi-fi world, this is what it's about. It's about connecting it all together, because I believe that if you understand sound, how sound is radiated from the beginning of the instrument, how it's captured, how it's reproduced and radiated into the venues and rooms, understanding the why of all of those steps and what we're trying to optimize, or at least trying to figure out. I don't claim to know the why, but I'm trying to figure it out and share with you, will help us become better engineers, better sound system technicians, and better sound system designers, speaker designers, or whatever it is. And that's what this is about. Instruments are not point sources. They're not point sources. They radiate different sounds in different directions. A violin, it's got the F holes and it's radiating off the body there, which sounds different than the back, which sounds different than the strings, which sounds different than where your fingers are and the bow and the body in the way. I mean, there's this asymmetrical, there's very little symmetry in instruments. Everything is kind of uneven. Even drum sets aren't symmetrical. Everything's humanly shaped and for playing, but even the symmetry in it. Yet sound systems are very symmetrical. So we got this asymmetry resonance going on. So different sounds in different directions. And since an instrument is not a point source, it matters where we put the microphones. If they were point sources, you could put a mic in multiple places and capture exactly the same sound. But that's not the case. And that helps us understand that mic placement is extremely important. and it'll change depending on where we place the mics. Sound systems are not point sources. There's a lot of chatter out there about manufacturers making a quote-unquote point source system. They're not point sources. A point source radiates the same sound in all directions. It's an infinitely small energy source radiating in a spherical pattern in every direction. And there are speakers, some hi-fi speakers strive to do it. The way to tell if something is a point source is to slice it. Take an imaginary knife and slice through the sound system. And after you've sliced horizontally, if the only thing you see is a point or a small area in relation to the wavelengths being reproduced, then it's acting like a point source. Then take that same sound system and slice it vertically. And if, again, you just see nothing but a small cross-section relative to the wavelengths being reproduced, you have a point source. Line arrays are not point sources sliced vertically. A horizontal slice of a line array, which gives us actually a really good point source in the horizontal domain, but in the vertical domain, it's not there. A band is not a point source. A band has multiple instruments located at distinct, separate places in space. You have a drum set here, a guitar here, a bass there, or violins, or you have a big band, you got your saxophones and your trombones and your rhythm section. It's not a point source. A band is a multitude of sources, with each source radiating a multitude of sounds in a multitude of directions. Quite the opposite of a point source. Pure tones are boring. Sine waves. Sine wave music, like maybe when we first had 8-bit audio, or even those weren't pure sine waves. They distort them, they fuzz them, they add some character to it. Something that just goes doo doo doo. In fact, we want the opposite. We want character, we want charisma, we want radiation, we want all kinds of varying overtones. So an electric guitar played directly into a clean DI box has no real depth or character to it. What do? We run it into an amp. We distort that amp. It's a tube amp. The tubes distort. We run it into a speaker. It's got a thin cone. That thin cone vibrates and breaks up and adds more character to it. They're a mess on purpose because solid tones are boring. Instruments strive for complexity. We want those resonant panels. We want that character. We want that irregular shape. We want everything to be a mess, and that makes it beautiful, like a tree. The difference between seeing a cell phone tower imitating to be a tree versus a real tree. One's beautiful and one's ugly. Nature, in its most geometrical, snowflakes or rock formations, still have aberrations that are gorgeous to us because their imperfections are what make them wonderful. That is what instruments are about. If you look at the difference between a guitar speaker and a PA speaker, the guitar speaker will be thin and break up and small voice coil, and the paper, will kind of be, talk. It's and the frames will be often sheet metal. A PA speaker will be rigid, very dead, very low resonance. And this is why when you put the guitar into the wedges, it never sounds like the way their amp sounds. Their amp adds all this beautiful overtone coloration, and you put it into the PA, and it takes it and tries to recreate it perfectly, when what we're actually looking for, what the guitar player is looking for, is a mess. A particular mess that is going to be very difficult to recreate. So we mic it and then run that in the speaker. Maybe we get close. But the only way to really get there would be drop a little miniature version of the guitar amp in front of them. When you mic an instrument, you are capturing one perspective of the infinite perspectives radiated by that instrument. You've chosen to place the mic in such a way to capture a single perception of that instrument. As you move the mic farther, you're grabbing more of those sounds that are being radiated. As you move it closer, you are grabbing less of those sounds. But you're still grabbing a single perspective, like taking a snapshot of the world around you. You're looking at and capturing that perspective. Each input added to a mix, whether it's a microphone, a direct input, or an effect channel, when that's added to the mix, you're adding that perspective to the mix. So a sound mix is an accumulation of multiple perspectives. Each output channel of the mix offers a single group of perspectives. So like the left output of your console offers a group of perspectives that you've chosen to send there. Whatever it is, this perspective of the guitar, this perspective of the snare, this perspective of the snare bottom, and so on. Each conventional speaker offers that group of perspectives to the audience or to the listener. And so if your left speaker has this group of perspectives and your right speaker has the exact same group of perspectives, or it might have a different group of perspectives. And you might have a rear speaker or an overhead speaker, a center speaker or side hangs. Those are groups of perspectives that we then offer to the listening audience. Offering the exact same perspective or group of perspectives to a listener from multiple distinct points in space is an unnatural event. That does not happen in nature. Everything that we hear, every perspective, comes from a different point in space, and no two points in space radiate the same perspective. It's like being in the Matrix or something. You go walk down the street and over here looks exactly the same as over there. You see the same thing twice. That is what happens if you run a stereo PA or multiple speakers in mono. Now, if you have a speaker covering an area with a perspective and you have another speaker covering another area, these people see this perspective and these people may see the same perspective. But they don't see both perspectives at the same time. That's when you run into issues. As we move around the real world, our perspective constantly changes. As we move around the listening world, our perspective constantly changes, except if you're wearing headphones, in which case you maintain your audio perspective regardless of where you go. This applies to in-ears. If you have in-ears in and you're on a stage that doesn't have stage noise or you can't hear the stage noise, your perspective is maintained. For better or for worse, it's something to know. Loudspeakers strive to radiate a fixed perspective evenly such that the same sound is heard throughout the listening area. And most technicians, most setups, most home hi-fi strives to recreate a single perspective and radiate that into the listening environment. In order for that to maintain its illusion, the person has to hold still, because the only time you're ever going to experience a single perspective in nature is if you don't move. As soon as you move, your ears and eyes and body expect a new perspective to be perceived. If we mess with that, which we can, and I'm not saying don't do it, it just will alter the way that people interact with their environment. It's not natural, but we may not want natural. Sending the same sound to multiple speakers covering the same area guarantees that you will maximize comb filtering, interference, and summation issues. Now, this is an interesting quandary because on one hand, we are striving, or people strive, to cover an entire listening area with the exact same perspective so that everyone has a similar auditory experience. And the natural thing that comes to mind to achieve that would be to send the same sound through all of the speakers so everybody hears the same thing. In that when you send the same sound to multiple speakers covering the same area, you guarantee that no two positions will have the same auditory experience. So what seems like the solution is actually the problem. Avoid doing the exact same thing to everything. We love patterns. We see patterns everywhere. You can tell the difference between wallpaper of ivy versus real ivy. There's a pattern there. There's a flat wall. Real versus fake. Any repetitive pattern catches our eye. When you do the same thing to everything, you're overlaying a pattern on your mix. For example, if you compress your entire left-right mix, that compression can be quite audible. Then people may try and break that up and do band limited compressing. That's to break up that pattern. If you use the same exact mic on every single instrument, some problem with that mic, a little peak, a little resonance, a little shrillness, or a little distortion will be overlaid on every instrument. It will add a plastic or non-realistic aspect to your mix. Anything you can do to create variations. We've got all these beautiful ways of making instruments complex and interesting. And each instrument is uniquely interesting. Putting the exact same distortion on every instrument is undesirable. That distortion works on guitar, but you don't want the same one on bass and the same one on vocals. Okay, so avoid doing the same thing to everything. For live shows, avoid amplifying the room back in to the room. You're already in the room. Taking and re-amplifying the room you're in back into the room you're in is an unrealistic and artificial sounding entity. Now, this is a bit of a quandary as well, because when you mic an instrument up close, the perspective you're getting is very close. It's detailed. You're getting only that specific part of the instrument. So the desire to move the mic back and capture more of the instrument is there and important. So you want to pull the mic back and get this more complex sound. But as you do that, you're also increasing the amount of room sound that is getting into that mic. The direct to reverberant sound the mic is picking up or is being, the direct sound is being diluted by the room. Now, it may sound better for that mic when it's on headphones or soloed. But it's also important to take into account that the other 23 mics you have on that band are doing the exact same thing. But each of those mics only gets that one instrument you're picking up. But they all pick up that same room resonance, that same kind of decay. So you've got 24 times the amount of room being picked up. And that's why when you solo all your mics, it sounds good. You bring up your whole mix, a lot of times it'll sound distant, disconnected, and not as tight anymore. Avoid re-amplifying the room within the room. If you have the channels, using multiple close mics to get a complex perspective, rather than a single mic farther away is one solution. If you want that more roomy, complex sound, put up a couple room mics or multiple room mics. Create faraway mics. That way, if you want more room sound, you can bring those up and add that room sound in. But if you don't want it, you can bring them down. If you mic everything at a distance to get that room sound, you're stuck with it. You can't take it out once the show starts. So having that flexibility to increase or decrease the reverberance of your mix by using up-close micings to capture everything and farther away mic as fill is a useful tool to use, as well as using reverberations of other rooms, realistic sounding reverbs that you can add in. Mic everything close and then add reverbs in that are manufactured. These are all ways to get around that issue. Okay, in my quest to combine the seemingly esoteric insanity of ultra hi-fi audiophiles, where everything has to be pushed to the level of perfection, against the messiness of overloading a guitar amp built out of flimsy wood that purposely resonates in ways that create all kinds of colorization and distortions, is fascinating. And I have more to come. And thank you for joining. Oh, one more thing. Let's give this a listen. This is a Columbia graphophone Type B from 1890. It plays cylinders, the oldest records, I think. Put that on there. It's got a little needle that rubs on there. This is the rewind button. This is the oldest version of the Sony Walkman. It's portable and it is wireless, which is very handy. Take this down to the beach and each one of these plays one song, so you can bring a nice wagon full of these to rock out, or just listen to the same song over and over again. It's portable. It goes into a little case here. It's got a nice little wood. It's got that thin wood, almost like a instrument wood. Beautiful piece. So let's go ahead and fire this thing up. This is really neat how it works too. It's got these little balls that spin, and as they spin faster, the centripetal force pushes them out and puts a brake on, and that's the speed control for it. All right, so let's go ahead and give it a try. It's my favorite song. All right, I got another one here. Let's try that. Good stuff. And they're kind of cone shaped. Put that on there. And okay, I think we're getting a little sleepy here. Battery's going down. Let's go ahead and get this charged up. This USB-C adapter here. Okay. Okay, I don't think they got signed. Good stuff. That must have been a demo. While we're messing around here, horns are just transformers. Acoustic transformers. They take and the relatively low impedance of a sound source, such as my voice, and it's a low impedance because I have a lot of power, and into the relatively high impedance of air, and we can hook up and tie that, and you could hear that it gets louder once it's, is it flashing? Alright, so there we go. This here really demonstrates my affinity for not using horns. They tend, now this is an extreme example, but they give you more output at the expense of frequency response and that narrower range. Okay, all for another day. Thank you for joining, and cool. Oh, I also want to mention I broke my wrist snowboarding, and kind of slowed me down from doing demos. So I'll continue to do videos, but put a little hitch in my get along here. And this is Deathbiter 2000, also known as DB. What a coincidence that name is.